Good morning, everyone. In this work, we are going to see synthesized characterization and electrochemical study of a new charge transfer complex between shift-based derivative and DGQ. Charge transfer complexes are well known in the fields of chemistry because of their huge applications in organic, green chemistry, biology, electrochemistry, quantum optics, and solar cells. First, going to see the synthesis of shift base. Shift base was synthesized by a one-part condensation reaction at 17 degrees Celsius for 3 hours in ethanol between the primary amine, naphthalene 2-amine, and 3 different aldehydes as shown in schema 1 and 2. Preparation of solid complex. Solid complexes were prepared by mixing an equal molar solution of the donor and the 3 acceptors in acetone trial separately. The mixture was left under stirring for 24 hours at a room temperature. A color changes was observed for the 3 complexes. ATTOU analysis and UV spectral analysis were carried out to investigate the formation of new compounds, as well as an electrochemical measurement was carried out to confirm the conductimetry behavior of these complexes. Results and discussion. Spectral analysis. The absorbance spectra of the donor acceptor and their complexes in the MSO are presenting in figure 1 table and table 1. As we can see, the free acceptor represents 3 intense bands, while the ligand display 4 strong bands. And interestingly, the city complex spectra shows 6 bands. These results confirm the interaction between the donor and the acceptor by the hyperchromic and hypochromic phenomena, as it is correlated with the electron transition of both of the donor and the acceptors. The FGL spectra of the ligand DGQ and the solid complex are presented in table 2 and figure 2. As we can see, shifts in the frequency is observed for the donor characteristic band and the absence of the band characteristic of the DGQ-CO and the appearance of new bands at 360-77 in the city complexes. This band is involved in charge transfer complexation with a deprotonating of CH of the donor. This change reflects a donor to acceptor charge transfer transition from P to P equal and from P to P equal type. Electrochemistry results. The conductivity of the city complexes was 2.5 microsiemens per centimeter. Open circuit potential. In order to determine the free potential of the CTC complex, an open circuit potential versus time curve is recorded for 2 hours in an aqueous solution. Voltammetry cyclic. In order to determine the redox couples, a cyclic voltammogram was recorded in a solution of CTC complex and tetrabutyl ammonium perchloride. The potential scan was carried out in the catalytic direction. The curve of the cyclic voltammetry recorded in a potential range of minus 0.1 volt to 1 volt by second at a rate of 50 millivolt by second. The electrochemistry confirmed that the solid city complex performed semiconductor properties, Nyquist and boiled. Metric impedance spectra are recorded for a frequency range from 100 kHz to 10 mHz at electrolyte equilibrium potential, with an amplitude of 10 millivolts. All measurements are taken at room temperature. Conclusion. In this study, we have synthesized novel charge transfer complexes, CTC, shift base, and DDQ. Electronic absorbance FGR were used to characterize the donor acceptor and the new city solid complexes. The formation of the new complex was confirmed by the spectral methods. Also, an electrochemical measurement was applied to study the behavior of CTC as semiconductors. And thank you for listening.